A few questions were left. We did till question 5, right? Question 6 and 7 I gave as homework. So did you do your homework questions?
Yeah.
Okay, any doubts in them?
No.
So now we shall be continuing with the 8th question, right? 1 second.
I also got my portion. And
Yeah, I checked. I received your exam portion. So we have to do after probability. 2 more chapters are left. So quickly we are going to complete probability. Most likely we are going to complete this lesson in today's class itself. And from the next class onwards, we are going to start ahead with the next 2 chapters. Okay?
Okay.
Yeah. And we also have your exam is on 15th, right? So we'll try to complete our syllabus by end of April so that we have a few days for revision as well.
Okay.
All right. So now we come to the next one. You have question 8. So question 8 reads, that Varun flips a coin, the 2 possible outcomes are heads and tails. And if the outcome are equally likely, what are the theoretical probabilities of each outcome? So basically, a coin has how many sides? It has either a heads or a tail, right? So the probability is 1 by 2, 1 by 2 only, because either you can get a head or you can get a tail. So the probability is 50% for each. So they are asking you, if the outcomes are equally likely, what are the theoretical probabilities of each outcome? So the first one will be, the probability is 1 by 2 for each outcome. Because if you're getting heads, then it is 1 by 2, because there are a total of 2 outcomes. Similarly, if you're getting tails, then again it is 1 by 2, because it is tails by yeah. So we come to the B part now. The B part says that Varun's results are shown in the table. Use the result to find the relative frequency of each outcome. So first of all, it is the outcome is given to you and the frequency is given. So what is the outcome? Heads 24, tails 16, and total frequency is 40. Right? So now, if I have to calculate the relative frequency, see, the experimental frequency is only there are 2 kinds of frequency. We have experimental and we have theoretical. So theoretical frequency is that you have equal chances of getting a head and a tail. For example, if you toss 100 times, so 50% of the times you can get heads, while other 50% of the time you can get tails, right? But now this is not the case. It might also be that you are getting 55 times head or 45 times tail. This is a chance event, right? So the result that we obtain might be different. So this is only that they are telling us, and now you have to calculate the experimental probability. So the probability of head will be (24 by 40), because 24 is the number of times that you're getting head and 40 is the total number of times that you've tossed the coin. So when you cancel it, what do you get, Hayah? Can I cancel it with 4? You get 10 times, and 4, 6 times. Again, you can cancel it.
Yeah.
You can cancel it directly with 8. 3 times and 5 times. So you have 3 by 5. Then similarly, the probability of tail it is equals to 16 by 40. Again, you can cancel it by 8, 2 by 5. So the total probability for head is 3 by 5 and for tail it is 2 by 5. Do you understand this part?
Yeah.
Okay, now it is given Varun's friend Toby says that Varun is not flipping the coin fairly because probabilities from the experiment are incorrect. What does Toby mean, and do you think that Toby is correct? No, Toby is not really correct, because the theoretical probability is a very fixed quantity. But in reality, when we are performing the experiments, it's not always the case that our probability is equal to the theoretical probability, right? Since like previously also I stated this point, if you're tossing a coin 100 times, it is not always fixed that 50% of the times you're getting head and other 50% of the times you're getting tail. You can even get 60 times head and 40 times tail. You can get 35 times heads and other 65 times tail. So probability can vary. But in general, the theoretical probability is 50-50. Do you understand this, Hayah?
Yeah.
Okay. Now we come to the ninth question. So ninth question is a similar type of question only. So please try to attempt ninth question.
Okay.
Do the ninth question.
Okay.
Yeah, Hayah, are you able to do?
Yes.
Okay. Hayah, shall we discuss the answer?
Yeah.
Okay, so tell me, you have the ninth one says a bag contains one white ball and one black ball and some red balls. Okay, so number of white balls is given. White is one. Black balls is also one. Number of red balls you don't know. Okay, but there are some red balls also. A ball is chosen without looking. If there are three red balls, work out the theoretical probability of choosing each color. Okay, so it is given, consider that number of red balls is 3. So the probability of choosing white ball will be, probability for white ball is, tell me, 1, because 1 is the number of the ball divided by total number of outcomes. What are the total number of outcomes, Hayah?
50.
By 50. How many number of balls are there?
5.
5. 5. 1 by 5. Then what is the probability for black ball?
1 by
1 by
5.
5 only. And for red ball?
3 by 5.
3 by 5. Okay. Then they are asking you, Daniel takes out one ball, records the color and replaces it in the bag. She does this 50 times. So total number of times that Daniel picks out a ball is 50. Right. Then she records her results in a table and outcome is given to you. Like outcome is white. So what is the frequency for white? 6. Then for black, 8. Then for red, 36. And finally total is 50. So this way you have to calculate the experimental probability now. So what is calculated is the theoretical probability. Now the experimental probability will be, tell me for the white ball.
6 over 50.
6 over
50.
for black ball.
8 over 50.
And for a red ball.
36 over 50.
36 over 50. Good. Then next you have is, Daniel knows that there are an odd number of red balls. What is the most likely number and give a reason for your answer?
Red ball, 5.
But the number of red balls is even. It's not odd. Why have they given you odd number of balls? See, if number of red balls is odd, so you can make one of the number of black balls or white ball as different. Then you can get red balls as odd. You can do one thing, please leave C part. I'll see to the C part and then we can have a discussion on it in the next class, okay?
Okay.
Next, you can come to question number 10. It says work with a partner to answer this question. This table shows 200 random digits generated by a spreadsheet. So if every digit from 0 to 9 is equally likely, what is the theoretical probability that a digit is 0? So for this, Hayah, you have to, it's a very simple question, but it's just lengthy. So for like, first you can calculate the number of outcomes. So you can multiply You count one line like this, and then you count all the boxes in a horizontal manner. Then you count all the boxes in a vertical way, and then you multiply the number. You will get total number of boxes. Okay, and then you just strike out how many zeros are there. Then you can calculate probability of zero. Similarly, A till F part you have. So this is an easy question only, just a lengthy question. So 10th question will be your homework. Right now, we can come to check your progress. Okay, of this lesson. So please start doing check your progress. Then we'll discuss it and we can move ahead. Okay, Hayah? Please start doing.
Okay. Teacher, I'm done.
Okay, so we shall discuss the answers. The first answer is, it reads, describe typical probability for an outcome that is very likely. So the probability of an event that is very likely. For example, um, consider a situation like there is like on second Saturday there is holiday in schools, let's suppose. So it is very likely that if this is a second Saturday, so it will be holiday only until and unless there is not some other event organized. So it is obviously a holiday. So it is very likely that it will be a holiday on this Saturday, right? If it is a second Saturday. So the probability is 100%. All right.
Okay.
The probability for an event that is very likely is 1 or 100%. Either you can write 1 or you can write 100%. Is impossible, so it's 0. So probability when something cannot happen only. For example, the sun rises from the west, so it is impossible. So it will be 0. Then has an even chance. So has an even chance will be what? Right, it won't do the first question.
50%.
50%. And that is unlikely.
25.
25 or basically less than 50%. Okay, then here is a set of cards with letters and the cards are placed face down. One card is chosen without looking. Find the probability that the letter chosen is A. So A occurs only one time. So the probability of the letter being A will be 1 by, what are the total number of cards?
1 over 10. 10.
9, 10. 1 by 10. Okay. Then probability that it will be I are 2. So 2 by 10. Then N is not there only. So it will be 0. And 4 is the word subtract. So for the word subtract, please see that let is in the word subtract. So the subtract word has S in it. For S it is 0. U, like for A it is 0. For R also it is 0. No, for R it is 1 by 10. For I it is 0. For T it is 2 by 10. Then for H it is 0. M it is 0. E it is 0. And I also again 0. So it will be 1 by 10 plus 2 by 10. So it becomes 3 by 10. Okay.
Okay.
Next is write down 2 equally likely outcomes for this set of cards. So equal outcomes are for T and I. For T also it is 2 by 10. For I also it is 2 by 10. Okay. Then next you have a spinner and find the theoretical probability of the spinner landing on each color. So like if it is landing on blue, then what is the probability?
12.5%.
Can you tell me in fraction, and please a little loudly?
Oh. 5. Oh, sorry. Yeah, 5 over 8.
Yeah, 5 over 8. For green?
1 over 8.
Okay, and for pink?
2 over 8.
2 over 8. Then next is a computer simulation gives these results for 200 spins. Green, pink, blue. So find out the experimental probability.
For green it's 18 over 50.
Why 50?
Sorry, 128.
Why 128? Tell me the reason. You divide it by total number of outcomes. So total number of outcomes will be 18 plus 54 plus 28. Total is 18 plus 54 plus 128.
Okay.
So 200. So 18 over 200. Next is 54 over 200. And next is 128 over 200. Please correct your answer. And now we have to
Yeah.
compare the theoretical and experimental probabilities. For green, see, these are the theoretical probabilities. While the ones on the right are experimental. So compare for green. Is 1 by 8 greater or 18 by 200 greater?
18 by 200.
Why? How did you compare?
Percent
How did you compare the probabilities, Hayah?
by taking out the percentage.
How did you take percentage for 1 by 8?
Mm.
Tell me, how will you find the percentage of 1 by 8?
Uh,
Hayah, did you attempt the questions?
yes.
So whatever you've done, please tell me. How did you do that?
So for A and B, I did all of it, but then C, you told me my answer is wrong.
I don't hear you, Hayah. Please speak loudly. For green, it is 1 by 8 and theoretical, and 18 by 200 experimental. So you can just cross multiply. So for green, just cross multiply 1 by 8 and 18 by 200 you have to compare. So comparison of fraction is by cross multiplication. So you get 200 into 1 and 18 into 8. 200 and 144. So 200 is greater. That means 1 by 8 is greater. So theoretical value for green is greater. Similarly, please do for blue and pink also.
Teacher, I'm done.
You have to tell me for blue which is greater, theoretical or experimental.
Experiment. Sorry, theoretical.
Theoretical is greater. And for pink,
Theoretical.
2 by 8 and no, you have 2 by 8 and you have to compare with 54 by 200. So again you cross multiply. So 2 into 200 and
Yes.
8 into 54, 400. Here 436 is greater.
Yes.
So experimental is greater for pink. Alright. Clear with this question, Hayah?
Yeah.
Okay, then you come to the next one. Seeds of a plant are sown in two different types of soils. 120 seeds are.
Teacher, I didn't do this as I did not understand any part.
Which one you didn't understand?
Question 4.
Question 4 only. Okay. So look
Yeah.
on the screen. Question 4 says seeds of a plant are sown in two different types of soil. So there is soil 1 and there is soil 2. There are two kinds of soils. So 120 seeds are sown in soil A. So soil A and soil B. So in soil A, how many seeds are there? 120 seeds. And 83 seeds grow successfully. How many grew from 120? 83 grow successfully. Then in soil B, a total of 70 seeds were sown, out of which 62 seeds were grown successfully. So which type of soil has better success rate? So easy, you can just calculate the probability of the seeds that are grown, okay, successfully. Like for soil A, the probability of seeds grown successfully will be 83 by how many total seeds were sown? 120. So 83 by 120. And then for soil B, you can also calculate the same thing. This is for soil A. This is for soil B. For soil B, it will be 62 by 75. Okay, and now you can just compare them. For soil A and soil B, just compare the probability. Cross multiply and compare. 83 multiplied with 75 and 62 multiplied with 120. So multiply and tell me the answers. Multiply
Okay.
it higher. And you can first copy it and then multiply and then tell me the correct answer. Okay. Copy it neatly. Write all the steps. Okay.
Okay. Teacher, I'm done.
Okay. Tell me the solution.
For 83 by 75, the answer is 6,225.
Speak again, Hayah. 83 multiplied by 75 is?
6,225.
Let me just check. 83 multiplied with 75. Okay, correct. Next, 62 multiplied with 120.
7,440.
So which is greater? 7,440. Clearly greater. So soil B has greater fertility. That means the seeds are growing at a much faster rate in soil B as compared to soil A. Do you understand?
Yeah.
Okay. So is this test clear to you?
Yes.
Check it. Okay, fine. So here now we are done with this chapter. You can just quickly go through the chapter, and if there is any topic, any doubt you have, so we can have a discussion on it.
Okay. Teacher, I'm done.
Yes, sir. Any doubts?
No.
Everything clear?
Yeah.
Okay. So Hayah, please positively send me the PDF of the next lesson that is coming in your exam. Before the next class, okay? Because in the next class we shall be starting with the new lesson. All right.
Okay.
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 So for today we'll just keep it up till here only. Also, please keep revising the previous chapters also before your exam. And if you have any doubts from this lesson also, you can ask me in the next class. We can have a discussion of the questions that you're not able to solve, right?
Yeah. Okay.
Okay. So you can go for today. We will continue it in the next class. Bye.
Okay. Thank you. Bye.